There are devices available that integrate a switch and a ground fault circuit interrupter, or GFCI, into one unit. These combination devices often find use in outdoor environments, for example, near swimming pools and spas, because of the heightened potential for electrical hazards. The device you encountered appears to fit this description. Regarding the dials located on top, they likely serve to fine-tune the GFCI's trip settings. The black dial usually adjusts the trip current, while the red dial modifies the trip time. As for the switch itself, it probably is a single pole type. This configuration means it regulates electrical flow through one circuit. Activating the top portion completes the circuit, which then turns the pool light on. Conversely, sliding the bottom portion leftward interrupts the circuit, thereby turning the pool light off. To elaborate further, the GFCI component is engineered to monitor the current balance within a circuit. Current should ideally flow from the source through the load and back to the source along designated conductors. If a discrepancy arises, such as current leaking to ground through an unintended path, the GFCI detects it. A ground fault happens when current deviates from its intended path and flows to ground. This situation can occur if someone touches a live wire or if there is a short circuit to a grounded object. GFCIs are designed to detect these ground faults and quickly interrupt the circuit to prevent electrical shock. In a standard electrical system, current flows from the hot wire through the device being powered and back to the neutral wire. The GFCI constantly monitors the current flowing in the hot and neutral wires. Under normal conditions, these currents should be equal. However, if a ground fault occurs, some of the current will flow through an unintended path to ground, causing an imbalance between the hot and neutral currents. The GFCI detects this imbalance and trips the circuit. The trip current is the amount of current imbalance that will cause the GFCI to trip. This current is typically very small, around 5 mA, to ensure that the GFCI trips quickly and prevents electrical shock. The trip time is the amount of time it takes for the GFCI to trip after detecting a ground fault. This time is also very short, typically less than 25 milliseconds, to minimize the duration of the electrical shock. GFCIs are designed to protect people from electrical shock by quickly interrupting the circuit when a ground fault is detected. They are required in many locations, such as bathrooms, kitchens, and outdoor areas, where there is a high risk of electrical shock. There are two main types of GFCIs: receptacle GFCIs and circuit breaker GFCIs. Receptacle GFCIs are installed in place of standard electrical outlets and provide protection only for devices plugged into that outlet. Circuit breaker GFCIs are installed in the electrical panel and provide protection for the entire circuit. The National Electrical Code, or NEC, provides detailed requirements for the installation and use of GFCIs. Article 210.8 of the NEC specifies where GFCI protection is required in dwelling units. For example, GFCI protection is required for all 125-volt, 15 and 20 amp receptacles in bathrooms, garages, and outdoors. Article 680 of the NEC covers the requirements for swimming pools, spas, and hot tubs. This article requires GFCI protection for all electrical equipment associated with these installations, including pool lights, pumps, and heaters. The adjustable trip settings in the GFCI allow you to customize the sensitivity of the device. Adjusting the trip current determines how much current imbalance will cause the GFCI to trip. A lower trip current will make the GFCI more sensitive and more likely to trip, while a higher trip current will make it less sensitive. Adjusting the trip time determines how quickly the GFCI will trip after detecting a ground fault. A shorter trip time will provide faster protection, but it may also cause nuisance tripping. When adjusting the trip settings, it is important to follow the manufacturer's instructions and to test the GFCI after making any changes. To test a GFCI, you can use a GFCI tester, which is a small device that plugs into the outlet and simulates a ground fault. The tester will cause the GFCI to trip, confirming that it is working properly. It is important to test GFCIs regularly, typically once a month, to ensure that they are functioning correctly. If a GFCI fails to trip during a test, it should be replaced immediately. In addition to GFCIs, there are other types of safety devices that can help protect against electrical shock. These include arc fault circuit interrupters, or RFCIs, and ground fault equipment protection devices, or GFEPs. RFCIs are designed to protect against electrical fires caused by arc faults. Arc faults are dangerous electrical discharges that can occur when there is damaged or deteriorated wiring. RFCIs detect these arc faults and quickly interrupt the circuit to prevent a fire. GFEPs are designed to protect equipment from damage caused by ground faults. They are typically used in industrial and commercial applications where there is a large amount of electrical equipment. GFEPs detect ground faults and reduce the amount of current flowing to ground, preventing damage to the equipment. When working with electrical systems, it is important to always follow safe work practices. These practices include wearing appropriate personal protective equipment, such as gloves and safety glasses, and using properly insulated tools. It is also important to de-energize the circuit before working on it and to verify that it is de-energized using a voltage tester. If you are not comfortable working with electrical systems, it is best to hire a qualified electrician. Working with electricity can be dangerous, and it is important to take all necessary precautions to prevent electrical shock or fire. The NEC provides detailed requirements for electrical installations to ensure safety. These requirements cover everything from the size of conductors to the type of overcurrent protection required. It is important to follow the NEC when installing or modifying electrical systems to ensure that they are safe and compliant. Understanding the principles of GFCI operation, the purpose of adjustable trip settings, and the importance of regular testing are crucial for maintaining electrical safety, particularly in environments with increased risk of electrical shock, like those around swimming pools and spas. Remember, electrical safety is paramount, and if there is any uncertainty or unfamiliarity with electrical components, consulting a qualified electrician is always the best course of action. Also, it's important to know the difference between a GFCI and a standard circuit breaker. A standard circuit breaker is designed to protect against overloads and short circuits. It trips when the current in a circuit exceeds the breaker's rated amperage. This prevents wires from overheating and potentially causing a fire. A GFCI, on the other hand, is designed to protect against ground faults. It trips when it detects an imbalance in the current flowing between the hot and neutral wires, indicating that current is leaking to ground. While a standard circuit breaker protects your electrical system from damage, a GFCI protects you from electrical shock. The NEC specifies where GFCI protection is required, and it's crucial to adhere to these requirements to ensure safety. The device you encountered likely combines both a standard circuit breaker function for overload and short circuit protection with GFCI protection for ground faults. This combination device provides comprehensive protection for both the electrical system and the people using it. Regarding the adjustment dials you observed, the black dial for trip current adjustment allows you to set the sensitivity of the GFCI. A low trip current setting will cause the GFCI to trip more easily, providing greater protection against smaller ground faults. However, it may also be more prone to nuisance tripping, where it trips unnecessarily due to minor current fluctuations. A higher trip current setting will make the GFCI less sensitive, reducing the likelihood of nuisance tripping but also potentially reducing the level of protection against smaller ground faults. The red dial for trip time adjustment allows you to set the speed at which the GFCI trips after detecting a ground fault. A shorter trip time will provide faster protection, minimizing the duration of an electrical shock. However, it may also increase the risk of nuisance tripping. A longer trip time will reduce the risk of nuisance tripping but may also increase the duration of an electrical shock. When adjusting these settings, it's important to consult the manufacturer's instructions and to understand the trade-offs between sensitivity, speed, and nuisance tripping. The goal is to find a balance that provides adequate protection without causing unnecessary interruptions. Remember to always test the GFCI after making any adjustments to ensure that it is functioning properly. Use a GFCI tester to simulate a ground fault and verify that the GFCI trips quickly and reliably. Regular testing is essential to ensure that the GFCI is providing the intended protection. If you ever encounter a GFCI that fails to trip during a test, replace it immediately. A malfunctioning GFCI is a serious safety hazard. The installation of swimming pool and spa electrical systems has very strict guidelines in Article 680. The equipotential bonding requirements are to create a conductive grid to minimize voltage gradients in the pool area. This bonding helps to ensure that if a fault occurs, the voltage difference between different points in the pool area is minimized, reducing the risk of electric shock. Bonding involves connecting all metallic parts of the pool structure, including the reinforcing steel, metal fittings, and any nearby metallic objects, to a common grounding point. The NEC also mandates specific wiring methods for pool electrical systems. Wiring must be installed in conduit, and the use of non-metallic conduit is often preferred to minimize the risk of corrosion. All electrical equipment associated with the pool, such as pumps, filters, and lights, must be listed for use in wet locations. This listing ensures that the equipment is designed to withstand the harsh environment around a pool. Also, there should be a method of disconnection for all electrical equipment that is readily accessible and within sight of the equipment. This allows for quick and easy shut-off of power in case of an emergency. Pool lights must be installed at a certain depth below the water surface to prevent accidental contact with swimmers. Underwater lighting must be specifically listed for underwater use and must be installed in accordance with the manufacturer's instructions. Regular inspections of pool electrical systems are essential to identify and correct any potential hazards. These inspections should be performed by a qualified electrician and should include a thorough examination of all wiring, equipment, and bonding connections. Any damaged or deteriorated components should be replaced immediately. By following these safety guidelines, you can help to ensure that swimming pools and spas are safe from electrical hazards. Remember, electricity and water can be a dangerous combination, and it's important to take all necessary precautions to protect yourself and others. Also, it is important to keep in mind that electrical codes and regulations can vary depending on the local jurisdiction. Be sure to consult with a qualified electrician to ensure that all electrical work is performed in accordance with the applicable codes and regulations. Ignoring electrical safety guidelines can have serious consequences, including electrical shock, fire, and even death. Take electrical safety seriously and always follow the necessary precautions to protect yourself and others. The information provided here is intended for general knowledge and informational purposes only and does not constitute professional advice. It is essential to consult with a qualified electrician for any electrical work or safety concerns.